Hello. In this video, we're going to look at graphing logarithms. Now, to start off, we're going to graph the most basic logarithm, just log x. Remember, of course, this means log base 10 of x. So how do we do this? How do we graph a logarithm? And just like most graphs, we're just going to go back to a table of values. This is a great method. If you don't know what you're doing, just go ahead and table of values. So x and y, which is equal to log x. Now we could try our normal numbers, -1, 0, 1. But log of -1 is going to be undefined because we can't take logs of negatives. Log of 0 is also undefined because we can't do log of 0. So this isn't looking great so far for our table, but let's do log of 1. That number we know is 0. So that kind of helps. But then if we keep going 2, 3, log of 2 is not a whole number. Unless we have a calculator handy, we don't know what it is. It's going to be some decimal. I mean, if you want, it's approximately 0.301, but that needs a calculator. And there's definitely going to be questions here where we don't have access to a calculator. So instead, what we need to do is we need to pick a smart value of x, or sometimes I think like a clever value, right? Here, this value is not great because it doesn't give us a whole number. But we need to pick some other value on here, some kind of clever value, so that we're going to get a whole number over here. Can you think of any x values that would be nice? Like, remember when we're doing square root graphs, right? We don't try to calculate the square root of 3 because that's not very nice. But the square root of 4 or the square root of 9, those are great values. Square root of 4 is 2, square root of 9 is 3. We pick values that square root easily so that we can determine the coordinates. All right, I think I'm thinking of one. If I picked 10, log of 10, what power of 10 do I need to get 10? That would be 1. So we're going to ignore this value, but we're going to keep these two. When x is 1, it goes in nicely. We get log of 1 is equal to 0, and when x is 10, log of 10 is 1. Now I know that's technically only 2 points, but with those 2 points, we should be able to get our graph. So at 1, we're going to have 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to have 1. So let's plot those points. 1 and 0, 10 and 1. But I mean, what are you supposed to do? Just like connect the dots? It's not totally clear. We need some shape. And the shape is going to come from this right here. The last value that you can't plug in, okay? This one right here is going to be your vertical asymptote. This is going to go right here at x equals 0. And so we know on this section, we're going to kind of have this shape as we approach the asymptote. Then we'll curve through here, and we'll keep going. Now, there's no horizontal asymptote, so we don't draw anything along like that. And so this arrow kind of just keeps going up. And there we go. We have our graph of log x. Now, if we wanted to be more precise, we could use a calculator or graphing software, but I think this is good enough. All right, let's try log base 2 of x. Again, we're going to start with a table of values. It's nice to start with 0 because the negative numbers we already know won't work, but 0 gives us that undefined, and that's going to be here, our vertical asymptote. Then we can do 1. Log base 2 of 1 is 0. And we can actually do 2 because log base 2 of 2 is 1. 2 ends up being our clever value. Now 3 won't work, but 4 does. Log base 2 of 4 is going to be 2. And if you wanted, there's another clever value as well. 8 would work. Log base 2 of 8 will be 3. Now the reason why I didn't pick more on that last question is the next clever value after log of 10 would be log of 100. Log of 100 is 2. But x equals 100 is so big on my x-axis, it's really hard to get a picture of it. That's why I didn't bother with another point. But here, I mean 8, we can get 8 on the graph. So let's go ahead and graph this. 1, 2, 3, 4, 5, 6, 7, 8. And we'll go up 1, 2, 3. So at 1 we get 0. At 2 we get 1. At 1, 2, 3, 4 we get 2. And at 8 we get 3. We get that vertical asymptote. X equals 0. And there's our graph. All right, so again, you get a couple points from your table of values. You throw down that asymptote, and you should be good to go. Now, what's interesting is if you imagine kind of like taking your phone and turning it sideways, or taking the whole screen and turning it sideways, this graph looks kind of similar to something you might have seen before. What I'm going to do is draw this. This is the line y equals x. And if we were to reflect this line over, if we were to reflect it, we would have a graph that looks like this. There'd be a point, instead of at 1, 0, it'd be at 0, 1. Instead of 2 and 1, it'd be 1 and 2. Instead of 4 and 2, it'd be 2 and 4. The asymptote here, oh sorry, I should do this in another color. The asymptote that was vertical would now be horizontal. And we would end up with a shape like this. Do you recognize that shape? You should. This is from our previous unit. This is y equals 2 to the power of x. And so what we notice here is that the exponential, y equals 2 to the x, is the inverse of the logarithm, y equals log base 2 of x. And this is very, very interesting. Y equals log 2 of x, and y equals 2 to the x. These are inverse functions. They're like the opposite of each other. How do you know that? How can we guarantee that? Well, what we could do is we could do, imagine this is our fx. And then imagine this is our f inverse. And we know that something is an inverse when f of f inverse of x just equals x. Well, let's try it. F of f inverse would mean we have to find log base 2 of, and everywhere we see the x, put in 2 to the x. Well, the exponent rule allows us to take this down, the log rule, x in front, log base 2 of 2. Log base 2 of 2 is 1, so we just get x. So yes, they are inverse functions of each other. They're the opposite. They work out perfectly this way. And so if you're really thinking about it, you could almost graph the logarithm by graphing the inverse, right? You could graph the exponential first, and then you get your logarithm. Now, I don't think that's the cleanest way to do it, but I just want you to notice here, right? When we're graphing an exponential, we might do 1, 2, 3. You know, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8. And so we're kind of doing the opposite, right? We're picking x values of 2, 4, 8. This is all very connected. Logarithms, exponentials, they're, again, two sides of the same coin. So it's a nice connection to see here. All right, so let's do a more complicated one. We have y equals log base 4 of x minus 2 plus 3. Now, again, I would recommend you do a table of values, but you're going to have to watch for the asymptote. It's going to be in a slightly different place. And then just for fun, let's go ahead and also state the domain and range for our answer. So go ahead and pause the video and give it a try. All right, so if we do x and y here, we're thinking about what would make the inside here equal to 0. So to get 0 from the inside, I think we need 2. Then we want the inside to be a 1. So let's just try 3. And we could try 4, see if that works. So when we plug in 2, we get log base 4 of 2 minus 2 plus 3. But of course, 2 minus 2 is 0. This is log base 4 of 0 plus 3. And we can't do undefined plus 3, so this is just undefined. When we do 3, we get log base 4 of 3 minus 1 plus 3. Or sorry, 3 minus 2 plus 3. which is log base 4 of 1. Now, whenever you have log of 1, you always get 0, so this is 0 plus 3, so 3. Now, if I try to do 4, 4 minus 2 plus 3, it's going to be log base 4 of 2. That's not really nice. I think I need to go up a little higher. So let's not do that. Let's try maybe 6. Log base 4 of 6 minus 2 plus 3. That'll be log base 4 of 4. Yeah, I'm feeling that. Log base 4 of 4 is 1. 1 plus 3 is 4. Again, you need to pick clever values so that the log of whatever evaluates nicely. And by nicely, I mean whole number. Okay. So we've got our points. Again, maybe I'm just going to clean this up a little bit here. So x and y, we had 2, 3, and 6. Although 2 here was going to be your vertical asymptote. 3 is 3. 6 is 4. All right. So vertical asymptote at 1, 2. Then we've got a point at 3, 4, 5, 6. At 3, it's going to be 1, 2, 3. And then at 6, it's going to be 4. All right, so again, 2 points might not seem like enough, but because we have that asymptote, we get the shape like this. And we're good to go. There's our graph of the logarithm. Real quick, we can write domain and range. The range is kind of the easiest one. If you notice, it goes all the way down, and then this way, right? It's going down forever. And it goes all the way up. It just keeps going and going and going. So the range is going to be minus infinity to infinity, or all real numbers. The domain, well, it doesn't get to the number 2. So we've got to put a 2 with a round bracket. But then it keeps going this way forever. So we're thinking infinity. All right. So go ahead and pause the video and try to graph this one. All right, assuming you gave it a try. Again, we can do a little table of values here. I think when x is 0, that'll give you a 0 inside. Then it looks like I'm going to need a 3 as a clever value and maybe 9. Let's try those out. Oh, maybe not even the 9. Maybe I'll need a 27. Oh, that might not be on the... Okay, well, we'll see. Maybe I'll be able to sketch it. Maybe I won't. Might need to have a pretty big x-axis, but let's give it a try. So when I do 0, I'm going to get negative 2 log base 3 of 0 over 3 minus 4. Now 0 over 3 will be 0, and so log of 0 is undefined, and that's going to generate my vertical asymptote. Now here I've got negative 2 log base 3 of 3 over 3 minus 4. That's going to be negative 2 log of 3 over 3. Well, 3 over 3 is 1. Log of 1 is 0. So I get negative 4 in the end. And then I've got log base 3 of 27. Maybe I don't need 27 over 3. Maybe 9 over 3 was a good idea, actually. Let's back that up. 9 over 3 minus 4, negative 2, log base 3. Yeah, that's working. There we go. That's going to give me 3. Log base 3 of 3 is 1, so minus 2 times 1 minus 4. That'll be minus 6. Now, I mean, if I wanted, maybe I'll do that 27 just to show. It seemed like a good point. I want to see here 27 over 3 minus 4. It's going to be negative 2 log base 3 of 9 minus 4. Log base 3 of 9 is 2, so minus 2 times 2 minus 4. So it'll be minus 8. That's the thing when you're doing a table of values here. You have to do a little trial and error, a little guess and check. you're picking values of x that are going to evaluate nicely in the logarithm, and sometimes you'll get it on the first try, and sometimes you need a little bit of help. All right, so let's go ahead and just clean up this table here. It looks a little wild. So we got x and y, we got 0, 3, and 9. I'm going to ignore that 27. I think it's too big to fit on the graph. This is my vertical asymptote. This is -4. This is -6. Okay. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. Vertical asymptote right there at 0. At 3, I'm at -4. And at 9, I'm at -6. So it looks like as I go through these points, I couldn't really do this, right? If I go here and then go down, that doesn't really make sense. It doesn't look like a log graph. So it looks like I'm actually coming from up top here and going down like this. The way I know this, of course, is because of the asymptote and the way the points are written. But also, if we look back at our original function, there's this negative here, and that means we're going to have that vertical reflection. And so we can kind of see that on the graph. It's been flipped around. Instead of starting low and going up, it's starting high and going down. Just for fun, we can state the domain and range. So the domain is 0 to infinity, and the range is -infinity to infinity. Okay, here's a weird one. Let's go ahead and graph y equals ln x. Remember, this means log base e of x. So pause the video and give it a try. All right, so hopefully you gave this a try. If we're looking at our x and y values here, when x is 0, we get ln of 0, which is undefined. So that asymptote's pretty quick. And when you do 1, ln of 1, well, what power of e do you need to get 1? It's still 0. So log of 1 is 0 no matter what log you're doing. That's nice. But if I tried to do 2, that's not going to work. 3, it's not going to work. I need a clever number over here. And I think the number I need is e. Because ln of e, which means log base e of e, what power of e do I need to get to e? The power I need is 1. So these are my clever values. Now, if you wanted to be extra clever, the next one here would be e squared, because ln of e squared would be 2. But this is kind of bonus. As long as you got 2 points, we should be good. All right, let's go ahead and set up my xy axis here. 1, 2, 3, 1, 2, 3. I got my vertical asymptote right here at 0. At 1, I got 0. Now e, remember e is 2.71. So e is kind of like right here on the axis, right? It's between 2 and 3. And so I got a point right there at e and 1. Then we connect the dots. Boom, we got our log graph. In this case, our ln graph. All right, so to really take it up a notch, go ahead and try to graph this. This is ln x minus 3 plus 1. Go ahead and pause the video and give it a try. Okay, you've got to be really clever with your xy axis here, your table. You got to start with 3, because ln of 3 minus 3 is going to be ln of 0 plus 1, and that's undefined. So that's going to give us our vertical asymptote. Then you can do 4, because ln of 4 minus 1 plus 1, sorry, 4 minus 3 plus 1, that'll be ln of 1, and that's going to be 0 plus 1, or 1. But now the next number we need is really weird, because if you try 5, right, you're going to get ln of 5 minus 3, which is ln of 2, and that's not a whole number. Not a whole number, which, yeah, you could try 6, right? It's not going to work. In fact, the number you're going to need here is e plus 3. I know, crazy number. Let's see what happens. ln of e plus 3 minus 3 plus 1 Well, those 3's cancel and get ln of e. ln of e is 1, and 1 plus 1 is 2. So this is not just a clever number, this is a very clever number. You got to add 3 to e, but as a number, I mean, it's still a number, right? E is 2.71, so 2.71 plus 3 would be 5.71. So it is a number. We don't know the exact decimals because we don't have a calculator, but we got a pretty good handle on it. And we should be good to go. So let's draw our axis. 1, 2, 3, 4, 5, 6. And then we know we're going up 1, 2. So at 3, we've got that vertical asymptote. At 4, we got the point at 1. And then at 5.7, so right here, this is probably e plus 3. We've got 2. Okay, so again, getting that second point was a little weird, but as long as we got really clever and thought about what needed to cancel with that minus 3, we should be good to go. All right, let's go ahead and take some notes on this. So this is graphing logarithms. And the basic method is use a table of values. You got to find the vertical asymptote, which is always when you have log of 0. That's going to give you your vertical asymptote. Then you have to pick clever values. So you get things like log base 2 of 2, log base 2 of 4, etc. Things that give you whole numbers. Things that evaluate, because you don't have a calculator. So you want your logarithms to work out nicely. And then from there you connect the dots. Just nice to remember that log base 2 of x, that's the inverse of 2 to the x. Maybe I could call this y. Right, those two are inverse functions, so just an interesting little fact. Now I'll go ahead and give you one here. So why don't you graph y equals log base 2 of 2x minus 4 plus 1. Y equals log base 2 of 2x minus 4 plus 1. Go ahead and pause the video and give that a try. All right, so assuming you give that a try, we have to think here that 2x minus 4 is a little tricky. You could factor it as 2 bracket x minus 2. That would kind of put it in the more proper form for transformations. And that'll show you right away that you need x equals 2 to get that 0 inside. So here we get log base 2 of 2 times 2 minus 4 plus 1. So that's log base 2 of 4 minus 4, which is 0. So that's going to be your vertical asymptote. Then you could try 3. Log base 2 of 2 times 3 minus 4 plus 1. So that's going to be log base 2 of 6 minus 4 is 2 plus 1. Log of base 2 of 2 is 1, so this is going to give you 1 plus 1, which is 2, so that kind of worked out nicely. Then we need one more number here. And again, on the inside, remember, we're trying to get nice numbers. So maybe on the inside, we're trying to get, let's say, a 4. So 2 times 4 is 8 minus 4 will be 4. So I think we can actually get away with a 4 here. It's kind of nice. 2, 3, 4. So we got 2 times 4 minus 4 plus 1. So that'll be log base 2 of 8 minus 4, so 4 plus 1, so that'll be 2 plus 1, so that'll be 3. All right, ran out of space here, so let's go ahead and just make a little more space down here. I've got my vertical asymptote at 2. I've got a point at 3 and 2. 3 and 2. And a point at 4 and 3. Connect the dots. And there's our graph. Now for some more practice, you can look at Unit 9, Worksheet 8, and then any things to remember. Again, maybe something to remember is that ln of E is equal to 1. That's an important number to remember in case you're trying to graph that ln graph. All right, hopefully you enjoyed this video, and as always, thanks for watching.